presentation that I'm sharing, you should be able to see the gdg.community page
Yes.
with our catchy line, imagine, innovate, impact. So
Yeah.
yeah, we try to bring expert speakers in our sessions, and we try to uh, spread the knowledge and have a positive impact in the community. So let's get started. So good to see you everyone here. My name is Darshan and I'm a co-organizer at GDG Surrey. We are a welcoming community where developers and tech enthusiasts from all, all around the place can gather and connect and learn together. Our mission extends beyond just technology. It's about empowering each other and to imagine, innovate, and make a positive impact, which is our tagline, you can say. Uh, so today we are pretty excited about focusing on the Road to Developer Certification series, targeting a professional machine learning certification from Google. This initiative is designed to elevate your skills in the cloud, Google Cloud technologies, and machine learning. Uh, we would like to take a moment and appreciate the GDG Surrey team members who have spent their valuable hours with us in organizing such kind of events and giving their valuable inputs. And I'm pretty excited to share with everyone that we are collaborating the whole series with GDG Seattle, bringing together the best uh, instructions and experts in the field. This partnership helps us ensure that all of you receive the top-notch guidance and support as you prepare for the certification. GDG Seattle team's expertise and support have been invaluable in making the certification series more and more meaningful. And yeah, I'm happy to share that David from GDG Seattle is joining us today. So if you have any GDG Seattle specific questions or anything, yeah, you can connect with David here as well. Yeah, so we had quite a few sessions in the past. Here are the some of the sessions that we had. For those who have missed the sessions, good thing is we record these sessions and we post them on YouTube. So you don't miss out on anything. You should be able to go to YouTube, uh, GDG Sari channel, and you'll be able to find all the sessions. We will be posting the session links in the chat during the session, so you'll be able to. Yeah, I would highly encourage you to bookmark the GDG Sari YouTube page so that you can stay updated with the upcoming sessions as well. Uh, and we would also post the Discord channel so that you can join our Discord community and stay updated with the GDG Seattle initiatives. Sorry, GDG Surrey initiatives. So yeah, our first speaker is Sam. Sam has a 10 years of experience in software industry. He is skilled as a software engineer and architect, and he lead teams to deliver successful projects across various domains. His expertise lies in web development, where he has consistently demonstrated his ability to innovate and drive efficiently. Recently, he made a decision to pivot his career towards entrepreneurship within real estate sector, leveraging his skills to identify and develop opportunities in this field. Alongside his ventures, he continues to offer his expertise as a consultant, helping organizations navigate technological challenges and optimize their software architecture for scalability and performance. Over to you, Sam. I would
Thank you so much.
stop my share. Yep. Go ahead, Sam.
Do you see my screen?
Yep.
Yeah.
Okay, perfect, awesome. It's you see my entire screen, right, for the slides?
Yes.
Okay, perfect. So thank you everyone for coming to my talk. This talk, like this title suggests, is some insights and stories from my career as a software engineer and software architect. I will talk about my experience on some projects that utilize AI and ML. But just a quick disclaimer, I'm not an expert in ML. I actually focus more on the software side of things. I often refer to myself as an AI integrator. I do have a lot of years of experience in software systems and scaling software systems from monolithic to distributed large systems in the cloud. So just to get started, I want to talk about my experience in fintech. This is a story in an AI fintech startup in Vancouver, BC. The company consisted of 20 to 30 people. There were 3 people in the data science team. It consisted of chief data scientist, a team lead, and an ML engineer. The project that I worked on was a web application that facilitated lending monies to small and medium-sized businesses. I'm just going to quickly walk through a flow to give you an idea what the system does. Imagine you are a small or medium-sized business owner, maybe a coffee shop or an ice cream shop. You walk into a bank looking for a loan. You talk to a specialist to gather your information, and they input it into the web portal. The system can quickly make a decision within 5 minutes to lend to you or not. Now, traditionally, this would actually take 1 to 2 weeks. The value proposition of the system in AI is that it significantly reduces the time to make a decision and lowers the barrier and requirements on a business credit specialist. This was the first time I worked at a company with a dedicated data science team. I got to witness firsthand how they were developing internal ML models. I got the experience to integrate these models into the platform and build other parts of the system as well. Our team and the data science team had different tools, languages, and processes. The platform team used frameworks like React, .NET Core, while the data science team used languages like Python. We both utilized the Azure cloud, but shout out to Google. You could definitely use GCP as well too. Talking a little bit about the ML models within the system, there were 2 major ML models, one for categorizing transactional data. So you can imagine your bank statements having many items. This model would categorize them into business expenses, rent, utilities, and many more other categorizations. This was actually kind of challenging between banks and credit unions because they would not have standardized text or standardized codes to represent them. So that's why the AI model was introduced. Another model that was utilized in this project was a model to determine lending to a borrower or not, and it will also provide proper justifications. Now, some of my takeaways from working at this place was it takes a large team to support an AI system, especially from the software side of things. We need to retrieve data. In this case, there was some data scraping required and also fetching data from different API sources, supply the data to the data models, store and maintain the results, and then show the results to the user. It might be through PDF reports or a UI. Something else I realized was large systems can have multiple ML models to support multiple flows or one flow. ML models, when integrated into a system, can feel very much like other services in a distributed system, especially if you're not actively working on developing the model. It just feels like you're integrating another microservice. Building ML models is an iterative process with potentially multiple versions. So the transaction model that I was talking about, originally it was actually built using if-else statements and regular expression statements. It wasn't until later on that AI model was actually added on. The credit model did not exist in the initial launch. ML was really added at a later time after onboarding multiple customers. Results and explainability was very important in the fintech space. Very oftentimes customers would ask, why did the AI model decide to lend to this customer versus another customer? And being audited by third-party consultants wasn't out of the norm. There was this one time we were onboarding a new customer, and as part of that onboarding process, they wanted to get a third-party consultant to audit the AI systems and the general system in total. So to transition away from that and talk about a more recent project in Airbnb regulations, as some of you might know, we are experiencing a housing crisis right now in Vancouver, BC, and Canada. There's a lack of housing supply for the given demand. So as you can see, I have this listing for a condo here that is $2,750 Canadian for a 1-bedroom apartment. This is incredibly expensive to me. Like, it's more than my mortgage, to be honest. So there are many contributing factors to this problem, such as interest rates, not building enough housing supply, not building the correct housing supply, investors and speculators taking up housing stock, empty and vacant homes, which kind of goes back to investors. They're buying up the stock and leaving it empty. Foreigners and students increasing demands. Among the many contributing factors, Airbnb and their host has been identified as part of the problem. Airbnb accommodations directly remove stock from the housing market, both the resales and the rental space. A property used for short-term rental is a property that could have gone to a homeowner or renter. The municipal government and provincial government understand these problems. That's why they have implemented regulations to limit Airbnb. Vancouver actually put limitations on short-term rentals back in 2019, while the BC government is putting in regulations starting the spring and summer. There are many regulations that they're going to put in place, but I'm going to talk about 2 of them. So one of them is short-term rentals must be licensed as a business. Business license must be displayed on short-term rental ads. Unfortunately, hosts don't always follow this rule. Airbnbs are not incentivized to remove these listings. So sometimes I will see them have exempt license, which is not a real thing, or they will have invalid license. So they'll put random garbage strings in the license area, or they might take an existing string and change a couple of the characters. We will also see reusing licenses on multiple properties, so like maybe 10 plus properties with the same host or multiple hosts. Another regulation that should be in place is that only primary residencies can be used for short-term rental. What that means is hosts must live in the property. With all that said, it is estimated that 40% or more properties listed in Vancouver are legal listings per current rules and regulations. I found that on Twitter. They either have invalid license or they are not primary residence occupied. It's easy to determine if a property has invalid business license. We can gather that information from Airbnb and then utilize Vancouver's data APIs to verify if a business license is valid or not. It is more difficult to determine if a property is occupied by a primary residence. There are certain ways to determine this as a human. Some of the things we can do is we can audit the text in the ad, and that can give hints. So if they use terms like suite, apartment, that can give away that it's probably not a primary resident. We can also analyze the images. That might give clues. So if we look at the images and they see it's an apartment, or if there's empty closets, that might give clues that it's not primary resident occupied. So I'm going to talk a little bit about the current state of the project. We have many discussions with stakeholders talking about Airbnb enforcement and the issues around that. We have had discussions with the BC government. They are optimistic about future enforcements, ensuring Airbnb participates in enforcement. The Vancouver government is actually waiting to see how the provincial government programs will work out. They have had a lot of issues in the past being able to regulate short-term rentals. Airbnb refuses to remove listings. They have issues finding hosts because they need to give the tickets to either the host or someone over the age of 16 that lives in the same property. And truthfully, not all problems can be solved with software and AI. Now, where we are technically is we're gathering the data. We're working on automating the process of gathering data from Airbnb and building an MVP on flagging illegal Airbnbs. We're iteratively building the system and integrating with existing AI models like ChatGPT and other large language models. Where I hope to be in the future state is have a stable system with rich data to add to public discussions. Some of the questions I am hoping to answer are Airbnb as big of an issue as people say it is? Do we need to focus on other housing issues like lack of supply? In the future, I'm hoping to also integrate more AI and ML into helping flag illegal Airbnbs and report them to government agencies. So final conclusions, recap, and final thoughts. I talked about my experience in fintech using AI to facilitate lending, talked about my project on Airbnb regulations for public interest. Some of my final thoughts are there are a lot of cool projects already using AI and ML, lots more projects in the pipelines from what I've seen. It takes a team to build meaningful systems and tools, a harmony between software engineers, ML engineers and data scientists is necessary. Building a large
I'm not sure. Sorry, I'm not sure if is it me or everybody lost Sam's audio?
No, I think we lost Sam. Yeah.
Okay.
Yeah. Yeah, we can just take a minute, see.
Oh, yeah, he dropped. I think something, yeah, with the connection.
Okay. Yeah. Meanwhile, we tried to connect with Sam. Yeah, it was good to see his experience, and he's able to, utilize the ML and artificial intelligence in, flagging out illegal Airbnbs. So yeah.
Oh yeah, it's a actually it's a very good problem to talk about and to work on. Because with all the housing crisis and the money that you get from working is not really it's they like there is no increase in that, right? Increment in that, but the housing prices are too much, then the rentals are too much, then Airbnbs are doing like whatever they are doing at the moment. So I think it's very important issue to talk about, and similar issues we as somebody who is tech enthusiast or in general want to make an impact on day-to-day lives or social, like society, can pick these issues and try to kind of come up with a solution, make a team, create, meet people like yourselves, create a team, and yeah, I think it would make it much easier for everybody, I guess.
Yeah, and I would love to know
Yeah.
how the solution of this problem that he's working on would make the end result, making the houses, I don't know, who knows, more realistic prices instead of, it would be great to see if we can get that kind of an output.
Yeah, somebody has to get started, and I think he did it. He is on a good start. Let me follow up with Sam for a minute, and we'll be back.
Okay, yeah. Oh, I guess he joined again.
What? When did I get lost?
Perfect. Yeah, Sam, I think we were on the conclusion talking about how we all can make meaningful solutions.
Okay. I apologize about that. I guess I lost power in my building. Yeah, I will just quickly go through my 2 slides. I actually only had 2 slides left, so.
Yes.
How do I share? Okay, sweet. So just to quickly recap, in my final thoughts are I talked about my experience in fintech space, helping facilitate lending, and my Airbnb project with public discourse. And some of my final thoughts are that there are a lot of there are a lot of AI and ML projects already happening, and there's a lot in the pipelines already from what I've seen. It takes a large team to build any AI system. It takes a harmony of software engineers, ML engineers, and data scientists to build anything meaningful. And it's an iterative process, so you can't arrive at the final product overnight. So just to plug myself with contact information, if you want to contact me for any reasons, please feel free to reach me at sam@samhul.com. And this QR code actually leads to my LinkedIn profile. I'm a consultant and contractor, so please feel free to reach out to me about any future projects that you might have. I love techs and love talking about tech. I'm trying to build a nonprofit organization called 𝗥𝗲𝗃𝗶𝗁, and that's where the Airbnb project is part of. I'm also a mentor with GDG Surrey, so you can feel free to reach out to me at our Discord. With that said, I'm finished with my presentation. So if there's any questions, please feel free to ask.
Yes, I think
I can't see the
have
chat,
some
by the way.
questions. Yeah, we have questions in Slido. Let me share the link again.
Okay, I'm only on one screen, so if you can read it up to me, that'd be awesome.
I will. Yeah, thank you. So the first question is, what type or types of AI ML frameworks did your team utilize? Did your team have preferences or rankings for models used in the fintech space?
Yeah, so there was actually a chief data scientist, and he made all the decisions on the AI models. I don't know how much I can share about exact models that we used. With that said, I know there were quite a bit of limitations on the data available to us, which hindered what models we could use. Like, it was quite often that the chief data scientist would say like, oh, I wanted to use this data model instead, but we don't have the data to support that.
Yeah. Thank you so much. Yeah, I think that's the point answer, and that I hope that's helpful. Please ask your questions. Next question is, please talk more about the data gather and cleansing phase issues and tips and suggestions.
For which project specifically? Or just both projects?
Yeah, it seems they might be asking in general. Yeah.
General.
Okay,
yeah.
Sure. I mean, like, data sources can come from anywhere, right? It could be on websites, and they might or might not have API integrations. So in cases where there are API integrations, that's pretty simple. You can just integrate with the AI, pull the data. You might need to store it in a repository like a database, or you might be able to push it directly into the data model. In some cases, and probably best practices is to sanitize the data, validate it, and make sure it's correct. In cases where there are no API integrations, you might have to do screen scraping and use screen scraping technologies. I hope that answers the question.
Perfect, Sam. We'll take one more question. What process did the team use for development? Was it Scrum or some other approach?
Usually we use Agile and Scrum. So there's quite a bit of material out there if you wanted to find out more about it already. Quite often we would do 2-week sprints and then daily Scrum meetings, stuff like that.
Perfect. Thank you so much, Sam. I believe it's okay. So we have more questions, but we have limited time. But I'll take the questions. Sorry, I would request you to take these questions still. Did your team have to pay for data for the housing issue?
With the Airbnb itself, no, we don't have to pay for the data. There are some cases that you might have to pay for data and you have to buy it. So like in the fintech space project specifically, I know they had a lot of issues getting the data. Like, it's hard to get banks to give you the data, etc. And then they try to reach out to this one company and they requested $1 million for providing some of the data to us. So it really depends on the project.
Perfect. And just a last question for this one. What database systems did the system use for this system? Document, relational, key value, etc.
So that question really, well, specifically, most of the time I use SQL solutions in Azure, but it really depends on the project, what type of data you might have. You might end up using a NoSQL solution or key value in some situations. That can actually be like a whole topic on itself of choosing the right database.
Yeah, exactly. For the rest of the questions for Sam, we'll answer them in Discord. We'll send it to Sam and he'll answer them in the Discord channel, and we can Darshan, we can move forward with the next topic. Thank you, Sam.
Yeah, definitely. Thank you so much, Sam, for
Thank you, everyone.
answering the questions and sharing your experience. Thanks a lot. Will share my screen again. Okay, so another speaker we have is Dr. Ryan Red. Dr. Ryan Red is an assistant professor at 𝗤𝗲𝗃𝗃 College of Computer Science, Northeastern University in Vancouver. Uh, his teaching portfolio includes courses in machine learning, algorithms, software engineering, data analytics, and data visualization, reflecting his commitment to educating next generation of computer scientists. He has an extensive background in both academia and industry. Dr. Rad's career encompasses significant roles as a researcher, engineer, team lead, product owner, and as an advisor. Uh, and he has been part of a variety of startups. Major corporations include Microsoft, where he delivered innovative AI solutions across sectors ranging from healthcare to sustainability. Uh, In addition to his professional practice, Dr. Rad actively contributes to scientific communities as a technical committee member, as well as speaker as a prestigious conferences and journals such as Institute Institute of Electrical Engineer and Electronics Engineers, Transaction on Image Processing, Transaction on Medical Imaging. He is also part of the International Conference on Computer Vision, as well as he is associated with the Association of Advancement of Artificial Intelligence. So, uh, yeah, glad we are glad to joining with Dr. Ryan Red, uh, uh, and he works not only pushes the boundaries of scientific innovation, but also served as a testament to the potential of responsible AI in addressing critical global challenges. So, thank you so much for joining, Dr. Red. Over to you.
Thank you very much, Darshan. I really appreciate your kind words. So let me just start sharing screen, and then we take it from there. Okay, so I guess you should be seeing my full screen. Okay, fantastic. Welcome to this session, everybody. Thank you very much for being here. And it's so great to see people from all over the world. So before I get started, I have to also say this. I have been on a very long flight yesterday. I flew over 20 hours. And so if I said something that doesn't make sense, don't blame machine learning. Okay, so it's just all me. Okay, so today we will be talking about, I think, machine learning in enterprise, and just to probably give you a super quick overview on where you stand in your journey. So the last session, I believe, has been on around feature engineering, and the next session is on computer vision fundamentals with Google Cloud. So today we will be focusing on machine learning in enterprise. So I will try to use our time as efficiently as possible. So I'm going to talk probably not for too long, 20, 25, 30 minutes max. And then, so hopefully we will have a lot of time for QA afterward. Okay, so today we're going to talk about model development. How do we build model, train model, and most importantly, how do we scale model training with a gigantic amount of data? And finally, we also talk about a model explainability, which is huge in terms of establishing trust in our models. So there are lots of steps when it comes to building a machine learning system. And so it goes all the way from ingesting data, getting all the raw data, making sense of it, doing feature engineering, and then and then working with that particular subset of the data to make a machine learning model that can be applied in a generic setup for unseen data, right? So there are lots of steps involved, and I think different people, you hear a lot of different terminology when it comes to categorizing these steps, and I really like actually Google's one, which says experimentation and operationalization. So what are these two terms about? So first of all, when it comes to experimentation, it comes down to defining a problem. And then based on that problem in hand, we're going to look into selecting data that is going to support solving that problem. And then we're going to start doing feature engineering, which is going to be making sense of those features, right? Making the data more informative and transforming it in a way that is easier for the model to learn from. And then we're going to go with building our very first model. And I oftentimes says, when you have your very first model, basically the life starts at that point. So some people think when you have your first trained model, oh, all good, we are done. Actually, life just begins there. So when you have your first trained model, you will go about evaluating your model rigorously, and then trying to come up with some ideas for further improvement. And that improvement going to goes on and on for weeks, months, years to come, and decades. So finally, so for that particular reason, that you need to keep your models updated, and I'm pretty sure everybody will be on board with us here why we need to keep our models updated. But I'm just going to add a little bit more just in case. So the world around us is changing every single day. So if you have a model that is working perfectly today, there's no guarantee that this is going to work as well for like tomorrow or the week after. We all have seen, for example, during pandemic, how people were behaving differently, right, than they used to behave for decades, for years. And obviously that change in terms of behavior will actually manifest itself in the change in the pattern of the data that your machine learning model has to deal with. And therefore, we have to continuously update and build new models that work better with the changing nature of the environment that surrounds all of us. Okay, so Google calls that part training operationalization, where you automatically go about fetching new data and then updating your model, training again on that data, and then pushing something to the production that makes a lot more sense than the previous version. And so what can go wrong with this process? Well, a lot of things can go wrong, right? But the two most common actually challenges that we deal with in machine learnings are underfitting and overfitting. And we're going to try to make sense of this. And I'm going to start by saying that there are always two different type of features or information in the data. So I'm going to call this, I'm going to call the first group data specific, or I'm going to say data set specific information, and then task specific information. So task specific information is everything about that particular task that we are trying to recognize or detect using our machine learning model. It has nothing to do with a specific set of data. For example, you might have, let's say you're doing some sort of posture estimation or posture detection using machine learning. So you have videos of people acting or performing, and then you want to kind of detect the pose. So in this particular case, the arrangement of the key components and those data points are going to be your task specific information. And now if your video has a watermark or has some certain type of noise that is captured by the camera or the device that has been used to record that video, that is going to be something I'm going to call data set specific feature. So we have data set specific feature and task specific feature, which is independent from that particular data set that you're working with. But data set specific feature is always only exclusive to that particular data set that you're working with. So what happens with machine learning is which one of these two set of information do we capture? And oftentimes one of these two are easier to capture, and you probably guess which one, right? That is the data set specific feature. So machine learning models are pretty smart with their learning algorithms. So what they try to do is they try to find the easiest, the fastest way to make sense of the word. And oftentimes that might not be the best way to make sense of things. So what happens is, I'm just going to show probably a very simple diagram here, which is capturing error versus model complexity. So this very, very simple diagram here kind of summarizes the whole idea or the whole challenge behind machine learning training and development. So what you want to do really is balance and find that sweet spot that that actually where your model complexity fits the task complexity that you have in hand. So whenever you don't have that fed, two things might happen, right? So first of all, this is the optimal region. You want to be around this region. You don't want to have models that are too complex or too simple, right? But if you have, then two things can happen, right? So if you're on the right side of this optimal region, what's going to happen is your model complexity is just too much that it doesn't need to work really hard finding task or capturing task dependent information. It can just look around the noises, like easiest stuff, memorizing the data and getting things done, but not in a substantial way, not in a way that it can be generalized to unseen data. And then on the left side of this spectrum, you have models that are too simple and they struggle a lot learning anything, not even data set specific information and feature, right? And this is called this region is called underfitting. So you obviously want to avoid these two, both like extreme ends of the model complexity, and you want to stay in between. And this is technically the whole challenge with machine learning. So whatever technique we're going to use is trying to make sure we stay within this optimal region, right? And so let me just show you quickly some learning curves. So you're seeing actually the training validation loss here, and this is pretty much a very, very common scenario. I have seen the exact same curve or very similar curve for a lot of different problems. And so what you see here is it's not a black and white world, right? So up to some points, your model is actually learning, right? But the problem is your model doesn't have too much capacity, or maybe there aren't really too much potential in your data. If you let this model train forever, bad things can happen, right? Down the road. For example, you can see that this model is doing very well until probably the 100 epoch, right? 100 iteration. So when we train this model for 100 iteration, up to 100 iteration, your model is learning, and what your model is learning is useful. And how do you know it's useful? By comparing your training loss versus validation loss, right? And then after that point, you basically see that these two curves are diverging, and you're still learning more. It seems like you are, right? So your model is still learning more, and your training error is going down. And this is the thing. Sometimes people think, oh, it's great, the training error is going down, so let's actually continue this forever, right? But the problem is it's heading to the wrong direction, because it's going down, but what it's learning is not useful. It's technically just starting to get distracted from the task specific information that I was actually talking about earlier. So how do we fix overfitting? There are a bunch of different techniques. The most common approach is regularization. We just gonna basically, when you add regularization, you're just making it a little bit harder for your model to overfit by telling your model, hey, you have all the power in the world, but I want you to be responsible in how you're using it, right? And then you can obviously reduce model complexity, like reducing the number of neurons, reducing the number of layers you have, and so on and so forth. But I'm going to also focus on the data perspective a little bit later. But for now, let's just focus on these two very, very common treatments for overfitting. And then on the other side of the spectrum, we also talked about underfitting. So where your model is just not powerful enough to capture anything from your data. So obviously, if you already have a lot of regularization, you need to basically cut down on those regularization to see what your model can do without any regularization. Oftentimes, it's a very good approach and practice to start training with no regularization at all to see if your model has enough capabilities to figure out the data, the complexity of the data. And if your model can do it, and then now you can further fine tune it and add regularization to get the best out of that potential out of that model. And so if you don't have any regularization, but underfitting is happening, then increasing your model complexity is going to be another step to follow. And then finally, probably better feature engineering. Again, these are one of the most common mistakes I see in junior engineers in industry is that they take feature engineering for granted. They take the data for granted. They're like, okay, that's the only way this data can be modeled and this problem can be framed. But there are always things that we can change on that, and we can bring in a new piece of data. We can try to make that data more informative. So it's not. So what I'm trying to say here is that if your model is not able to learn, it's not the model's fault necessarily. It might be your data fault as well, right? So we shouldn't be too quick in terms of kind of judging the situation and coming up with one particular treatment, right? So oftentimes we prioritize, right? It's most likely to be for this particular reason, and we're gonna check that, we're gonna test that, we're gonna validate. If that's not the case, then we're gonna go to the second item in the list and keep going, right? So sometimes you have multiple factors that are playing the role. That's also another thing. But oftentimes, so this is the data's perspective. Actually, working with higher quality data and more insightful data can help with both overfitting and underfitting. And so this can be a tricky area. So a lot of times in industry, one of the main problems, for example, people have is having a lot of data, a lot more than they can possibly handle. So so while this is a good problem to have, right, having a lot of data, but it can be overwhelming, and it can put a lot of pressure on teams. Like, so you have billions of data points. Why you can't make this model predict accurately, right? So oftentimes there's a lot of pressure, and your experiments will be more and more expensive. So the more data you have, the longer it's going to take. And we're going to talk about that. That's the next point here. But one of the things that I love about Vertex AI is that Google does this cataloging for you automatically, and this is just so amazing. And let me break it down for you. So let's say you're working on a very important, impactful problem in industry, and you're dealing with millions of data points from real people in the world, and you are measuring your model's accuracy, or in whatever metrics that you have, you're checking the performance of that model. But let's say your model has a performance score of 89% in like, regardless of what is the nature of that metric. Now, that's just an average number, right? So there might be some set of data with some specific characteristics that your model is doing horribly bad, and there might be some type of data that your model is always getting 100% accuracy. So looking into metadata and looking into data, basically catalog, can help you make sense of all of those things, right? And Vertex AI does this automatically for you, regardless of the format of your input data. And that's the beauty of it. So whether you have text data, whether you have videos, images, Vertex AI automatically extracts metadata for you and classify that, and you can now use all that data to find more relevant, higher quality data for your next training. So instead of dealing with billions of data points that a lot of them might not be very valuable to your training, you can focus on a subset of the data that can make your model learn much faster, much better, right? So that's about data catalog. And then we were talking about a gigantic amount of data, right? So that's a real thing. So we used to train machine learning model like 10 years, 12 years ago. We used to build machine learning models with a few hundreds of data points. Today, we actually build machine learning models with millions easily less, like 5-6 million is not a big number right now for ML, and sometimes billions of data points. So how can we actually make training faster? Because they get slower and slower with more data, which is supposed to be a good thing, I assume. So one approach is basically doing some data parallelization, and so in a way that if you have multiple workers or multiple machines, each multiple workers, they can each work on a separate chunk of data, and then they're going to calculate the gradient, and we can update the model parameters based on all those gradients that we're getting from the workers. So there are two ways this can actually be done. One is the async parameter server, and then the other one is the sync or reduce. And I'm going to quickly go over both of this. So let's say you have a bunch of workers, and you want to make use of all of those, and then you can also have parameter servers which actually holds the set of parameters for you, and then each of these workers will fetch the latest parameter, the latest set of the parameters from those parameter servers, and then they're going to work on that individually and independently, right? So each of these workers will fetch the parameters and try to calculate the gradient on their input batch. And then when they are done, they will return the gradient into those parameter servers, right? So there are good things and bad things about this, obviously. So the good thing, well, let's just start with the good thing always. So the good thing here is that if you have workers that are not reliable, or if you have network issues and so many other problems that are very common, this is not going to cause a threat to your scalability. Why is that? So if, let's say, worker 2 is down, this is not going to slow down, or this is not going to pause anything here. We're going to keep going because the workers are not waiting for each other, right? So that's a great thing. But what can go wrong here is that they can actually easily get out of sync. And when they get out of sync, there is a chance that your worker, one particular worker, is working on parameters that are not actually the updated one. They're working on stale parameters. And another problem here is that that's one thing, right? So your different workers are not sync, right? And then okay, so this is a good thing, right? So when used in the right situation and for the right reason. So when you have workers that are not reliable, we said, and you have workers that are not super fast, this might actually be a very good strategy. But in today's world, we have easily access to GPUs and TPUs. So this might be a completely different a setup than the best use case for async parameter server. So a better way, when you have better workers or faster worker, is going to be using sync or reduce. So the way this is going to work is we don't need actually parameter server anymore. And each worker can actually maintain the set of parameters, and they can work on their data chunks separately, and they can communicate with each other. And Now, so something I think I wanted to say in the previous method and I forgot was there is another thing this can actually be a bad idea when your workers are not totally balanced in terms of their abilities. So let's say worker number 1 or worker number 0 is extremely fast or much faster than any other workers. Then what's going to happen is this worker is going to try to communicate a lot with your parameter server, right? So it's going to just there's going to be always communication, and that's going to create a problem for your workflow. But now, in terms of sync or reduce architecture, these workers are going to communicate with each other. And here is something you need to pay attention to. The next iteration will not begin until all this communication is performed. So workers going to wait for each other. They're going to wait for each other. They're going to hear from all other workers, and then they're going to get the parameters updated, and then the next iteration going to start, which is very different from the previous case, right? So in previous case, they're not going to wait for each other. They can actually do their things independently. Now, when do you use this one versus the other one? So there are a couple of considerations. There's no right or single answer here. But if you have lots of workers that are extremely fast in terms of computation, you better go with or reduce. If you have workers that have reliability issue, or they're just CPUs, they're not GPU or TPU, then you might actually be much better off going with the parameter server architecture. And another thing is, what is going to be your performance constraint? What is going to be your main performance bottleneck? So if you're going to have a lot of I/O, then probably async approach is going to be better. And if you have a task which is going to be heavy on computation, but you don't have a lot of I/O, but you have a lot of computation to do, you better do the sync or reduce with faster GPUs. But whether this one or that one, we need one of these two mechanisms in order to scale training. Otherwise, it's going to be extremely hard to scale any machine learning development model. And the sync or reduce one is the most common one I think we see today. There are lots of different products that are built using sync or reduce. And okay, so finally, this is the final item we have here before we start our QA. And this is going to be model explainability. So machine learning models have, for a very long time, they have this reputation of being a black box, right? So if you can build an amazing machine learning model that can do something a very difficult task with a substantial accuracy, that's all great, that's amazing. But how can we trust, right? So I think for human being, things that we cannot see, we cannot observe, we cannot explain, are kind of hard to trust, right? And so, for example, imagine we have a machine learning model that actually come up with the best prescription for someone who has some medical issues. And regardless of how much I tell you this model has been tested very comprehensively and has a very good accuracy, has been developed over decades, these are not going to be enough, right? So you want to know how the model does what it does. And if you understand how the model does what it does, that can help us establish trust, and we can use this model on critical applications. Okay, so this is going to be a little bit tricky for some machine learning models, right? For some machine learning models, this is going to be quite easy. Let's say if you're building a decision tree, which is one of my favorite machine learning models. If you are building a decision tree, regardless of how complex your data or task is, if you just look into your decision tree, it's really easy to kind of explain how your decision tree does the prediction, right? So you're going to look into up to the tree, closer to the root. So the questions that appear first, they are going to be the most important question that your model is looking at in order to make its prediction, right? But wait a second. how actually we can make a neural net explainable. So this is going to be the tricky part. So one of the techniques that actually people use is the gradient-based attribution. So so we're going to create attribution using a gradient of the output that we're going to produce with respect to each base input feature. Now, let me explain this a little bit better. So so what we want to do here is we want to start with a base image, which is technically nothing. So let's say it's all black pixels. There are no information there. And then we're going to kind of create this linear interpolation from that base image all the way to the input image. And then at each step, we're going to look into how much changes that we're going to introduce to each pixel in that image is going to contribute to how much changes in terms of the predicted image. And then if we scale those gradients, we're going to actually come up with something like this, which is going to explain what your model is looking at in order to make the prediction that it does. Right. So so this gradient-based attribution is one of the most common and most popular approach when it comes to dealing with visual data, which we do a lot nowadays, right? So whenever you're dealing with images, with videos, this is going to be oftentimes a very good kind of approach to gain some insight into how your model does what it does, right? So what are the attributes that your model going to look at and pay attention in order to make the prediction? Okay, so that was our quick review of the machine learning in enterprise. And let's quickly look into, I guess, 3 sample question here, and then we're going to open up the floor, I think, for QA. So some sample question. I'm not sure what's the best way to do it, but maybe you can just put it in the chat, and let's see, what do you think? And so model complexity often refers to the number of features or terms included in a given predictive model. So now what happens when complexity of the model increases? So you have a bunch of options here. We are talking about a model that is very complex, right? And so model performance on a test set is going to be poor. Model is likely to overfit. Model will not figure out general relationship in the data. So I see answers are coming in. That's great. I have 5 answers yet. So I'm going to wait for at least another 5, and then we're going to see what we have. So I'm going to be quiet. Yeah, feel free to change your answer. That's perfectly fine too, right? Okay, so we have a good distribution, but mostly the answers are around B and C, I guess. So we get a lot of, we're getting a lot of B and Cs. So the thing here is you just need to really look into the things from broad perspective, right? So when your model is actually overfitting, what does that mean? Doesn't that actually mean that the performance is going to be very poor on the test set, right? So it's almost guaranteed, right? So if your model is overfitting, so whether you're saying B or C, you agree that your model is overfitting, right? So I'm taking that common trend there. So I think a lot of you agree that this model is likely to overfit. So when a model overfits, it's like with almost it's almost guaranteed that the performance on test set is going to be poor, right? And why the performance on the test set is going to be poor? Because your model did not quite figure out the general relationship in the data, right? So so therefore, so C is correct, right? But the most correct answer here was A was also correct, and I know some people said A, but the most correct answer here is B, because both A, C, and D, actually the 3 of them are all correct. Okay, great. Let's do another one. You need to write a generic test to verify whether a dense neural network, so we're talking about a neural network here, right? So you need to write a generic test to verify whether your dense neural net model can automatically released by your team have a sufficient number of parameters to learn the task for which they were built. What should you do? So let's read the question one more time. You need to write a generic test to verify whether a DNN model automatically released by your team have sufficient number of parameters. So technically, if I want to just say this in a different way, you want to make sure that your model is not underfitting. So if you want to make sure that your model is not underfitting, what would you do? And this is also this also talks about a good first step, a good first common practice when it comes to training a model. So you're just starting building a model, right? Okay, you're just starting building a model. And what is the first approach that you do? It doesn't have to be perfect, right? Because you're going to keep building on it, right? So some of this might not quite help, right? So I'm just going to yeah, so perfect. So the answers are coming in. Nobody said A so far. That's good because A is not the answer. So train the model for a few iteration and check for NaN values. So it doesn't really tell us our model has sufficient number of parameters, right? It might be because of something else. So if you don't have the right loss function, you might get NaN values. It has nothing to do with sufficient number of parameters, right? So A, therefore, obviously cannot be the answer here. So training for few iteration is not the answer. So then now between C and D, train a simple linear model and determine if model DNN outperforms it. So creating a baseline, right? So again, this might be a little bit tricky, but think about the simplest. I think I did mention in this presentation actually earlier that it's always a good idea to start. I think that was the sentence that we used here. It's always a good idea to start with when you're building a model, right? So so C probably not, I mean, not directly the best idea here because you're training technically a base model and for comparison. It does not necessarily tells you whether you have enough numbers of. Yes, A and B are not. A and B are wrong. We're now down to C and D and see what happens there. So I'm just trying to see if I can steer you in the right direction and if we can get a unanimous vote on one of these two. Okay, I can see a pattern. The more I explain, I think more people are going toward D. And so D is the right answer here. But why C is not correct? I also want to explain that a little bit. Why C is not correct? C, when you do C, you're creating a baseline and you want to compare these two. This comparison does not necessarily tells you whether your DNN models has insufficient parameters, right? Yeah, it's like apples and oranges. They're not the same model. They're different family of models. And whether your DNN does better or worse, it doesn't actually tell us whether it has sufficient. So the only direct way is starting with no regularization. So this is something we also mentioned today, right? So when you start, don't bother. Just let your model do whatever it wants, because that way you can make sure that your model has sufficient parameters to learn or not, right? And if your model does, so another way to say this is some people say, I don't like that wording, but some people say, let your model overfit first, right? Some people say this. I prefer to say that do not use regularization than letting your model overfit. So that's it. And one last question here. So you work for a textile manufacturer and you have asked to build a model to detect and classify fabric defects. You train a machine learning model with high recall based on high resolution input images that taken at the end of the production line. Now, what you want to do is you want quality control inspector to gain trust. So we are talking about model explainability that we kind of discussed just 5 minutes ago, right? So how do we gain trust in our model? And in your particular model, in this case, we are using a neural net that is taking, so some sort of convolutional neural net, right? So we are dealing with images here. Which technique you think we should be using to understand the rationale of our classifier? Because understanding that rationale can help us build trust and use this model in real world. So answers are coming. I'm trying to maintain a poker face, so I'm not giving up the answer. Okay, fantastic. I think we got a lot of B's, right? So B is the right answer, right? So we talked about integrated gradient or attribution, right? To kind of make sense of how the model does prediction on images, and creating and getting insight through that prediction process. So the correct answer here is B, and because that's the only one that actually gives us some information about how this model does the prediction, right? So making sense of the process and the prediction quality. Okay, so that is the end of I think our my part of this. And thank you very much, everybody, for being here today and for listening. And I'm going to be open to QA. Pretty, I think we can take as many questions as possible for I think about 20 minutes.
Thank you, Ryan, for such a detailed session. And I think everybody got to learn the model complexity, and explainability. Let's quickly do the Q&A. I can read them for you. First question: can you go over the rationale for the dense neural network answers again, please?
Dense neural network answer. Yeah, absolutely. So let me just go back. For some reason I lost. Okay, now I have it back. Control over. Okay, so the dense, I think this one, right? So we're talking about this one. So what you're trying to do here is, the question is talking about, you want to make sure that your model has sufficient parameters, right? So you want to make sure that your model is not underfitting. Okay, so if your model does not have sufficient number of parameters, your model will be underfitting. So that's technically what you're trying to do, right? So if you do use regularization, you won't be able. So the thing here is, let me put it this way: you just want to isolate things, right? So to make sure that you understand what component in your training pipeline is causing the outcome that is undesirable, right? So if you combine regularization with your choice of model, then you don't know which one is causing the problem, right? So it's certainly, for sure, if you use a lot of regularization on any machine learning models, you will be killing the model, right? So too much regularization on any model will cause your model look like it doesn't have sufficient parameters, right? So that is technically the reason we're kind of decoupling. We're saying that, okay, no regularization at first, add it later, because that's going to help you understand whether your model has the basic capabilities to understand the task and understand the data, right? So I hope that was helpful, but feel free to follow up.
Thank you. Next question will be: are high dimensional models more difficult to control for errors in addition to over-underfitting?
Right. So high dimensional models are more difficult to control for errors in addition to more difficult to control. So I'm just trying to guess which angle you're going with this. So I assume part of the question is for diagnostic, right? So if you, for example, if you're not getting what we are supposed to get, right? If the model is not performing well enough, then how do we, is it going to be more difficult to do it when the model is overly complex, or it's going to be easier to do it? So obviously you're right. I think the answer is yes. A more complex model is going to be more difficult to control, other than underfitting and overfitting, right? So oftentimes in machine learning, you want the simplest model, the simplest possible model that gets the job done, right? Because with more complex model, there are many problems that might happen, right? So more complex model are hard to control. Even if you're getting it into the work once, it might not be easy to make it work again if you try tomorrow, regardless of your environment and how much control you're putting in, right? With a little bit of so I guess the other thing here is we can also look into. So this is one of the topic that we didn't discuss today because it was just an overview, right? But bias and variance, right? So a more complex model oftentimes get you a better bias at the cost of variance, right? So you're going to get a lot of variance for that model, but the bias is low. And that's why we like that model, but we hate that model because the variance is too high. And when the variance is too high, another problem is that regardless of your overall performance, your model will act differently, or sometimes substantially differently, on a different similar set of images or input data, right? So although your average results are high enough or good enough, you might get a totally different error or a totally different result when you change your input data, right? And that actually comes down to the problem of high variance. But yeah, so again, that was the long answer. Short answer, definitely. And that's exactly why we don't like complex models, right? So oftentimes what I do, and what I see a lot of people do, is start with the simplest model with no regularization, add complexity as you go, and until it's enough to get the work done.
Perfect. Thank you, Ryan. Next question is, how can we determine if we have collected enough data? I have always believed the more data is better. Yeah, I think this question will answer for many people.
Yeah, so another very good question. How do we know we have enough data, right? So this is the number one thing is so in machine learning, like we oftentimes say that it's trial and error, but not really, because the number of items you can actually do experiment with is just going to be so many all the time that you're always going to run out of time and resources to try everything, right? So in machine learning, we do trial and error, but we do it in the best educated possible way, right? So now your question, how do I know, put it into the test, right? So it depends on the task, right? It depends on your data as well. So not every single data point is equally significant, right? So just like us human, oftentimes we see a lot of examples every day. Not every example is informative, right? Not every example is useful enough. So oftentimes it's not about the quality of your data. Sorry, it's not about the quantity of your data. It's about the quality of your data. Sometimes 1,000 images might be good enough. Sometimes 10,000 is not nearly enough, right? Also depends on the quality of your annotation and so on and so forth. But to directly answer so that was just for the context. But how do I know if I have enough data? I would say test it, right? So have a decent test set, and have a decent independent test set, and see if you can generalize, right, from the input data that you have, and then add more until it can get the job done, right? And start with a simple model, right? And this is also a twofold problem. Whenever you're building something from scratch, you're probably going to have a hard time deciding whether I have enough data or whether my model is. So my model is not learning. Is it because I don't have enough data, or is it because my model is too simple? Oftentimes the answer is both. Or to some extent, both of them are contributing, right? But the thing here is that regardless of how much data you have, we want to be able to see how much we can learn from it, right? Now, Sometimes that learning is enough. Sometimes that learning is not satisfactory. But the short answer there is experiment with it, right? And that's the only one data-driven, number-driven approach. I can tell you, there's no one in the world that can actually look into a problem and look into the data and actually tells you that by 100% confidence, this is going to be enough data for this problem, or no, you're going to be. Of course, we can come up with an estimate, but the range is going to be very broad unless you try.
Awesome. I think, with these questions, I think it's kind of revision that I'm getting, and it's literally going back to my class and learning everything over again. So great, Ryan, thank you. I'll go with another question. For embedded systems, should we be using async parameter server?
For embedded systems, yeah. So when it comes to embedded systems, I assume so there are two things here. Number one is you're using you're using an edge device or an embedded system to do the inference, or you're actually training on an edge device. So oftentimes we do not train on an edge device, right? That would just not be the best use of your environment. Oftentimes we only do inference on the embedded system and on the edge device. So doing that separation, you can do both, basically async or sync, and because it just doesn't affect your inference environment, right? So, but again, the answer here is, like, in today's world, we're going to use sync or reduce pretty much all the time, right? Pretty much all the time, because for two reasons, right? Number one, fast, reliable computation is just so easily accessible, right? And then the second thing here is you have a lot of data, right? So you have lots of data, and then you have reliable and fast computational cores, and therefore it's always going to make more sense to use sync or reduce over async.
Perfect. I think we'll take two more questions, and rest questions we can answer in Discord later. So I'm going to club this question. Please comment further feature engineering and on how ensemble models can be used to reduce overall model complexity. Do ensemble models have more of a tendency to having over-underfitting issues?
That's a very good question too. We're getting a lot of good questions, so that's amazing. And so we're talking about ensemble models, and then I'm just gonna build a context for those who might not be super familiar. So when we talk about ensemble models, it's it's just a fancy term to say we are trying to build a machine learning model on the top of multiple models, right? So in this particular case, you don't have a single model. You have a group of models that are working together to make the prediction happen, right? So that's called ensemble models. Okay, so there are different type of ensemble models, and the answer depends on the type. Okay, so some of them help you with the bias. Some of them help you with the variance, right? So these are just two sources of error, bias and variance. So I'm not sure if everyone is familiar here, but one of the two examples that I'm going to put forward is going to be bagging versus boosting. So bagging and boostings are two ensemble techniques, and one of them will build a model sequentially on the top of the previous trained models. So technically, you build a model and you test that model, how great that model is working on the real world data, and then based on the feedback you get, you further train it again. So things are happening sequentially here. And then the boosting, the other type is when you train all this model in parallel, all at the same time. So, and then at the end of the day, you're going to get an average of the results, right? So now, if I want to ask you to kind of guess which one is helping with bias, which one is helping with variance, I guess a lot of you would agree that the first method helps specifically with improving the bias, because you're sequentially, you're training a model, you're seeing in what area that model is not super helpful, and then you're giving that model a second chance, right? And a third chance, and a fourth chance, and a fifth chance. So your model can build on the mistakes and whatever it has learned before, and it just gets better and better and better every single time. So this is going to help with the bias, right? And then the second approach, when you actually in parallel, you train all these models and then you take an average out of those three, that is going to be extremely helpful when it comes to variance, right? So you have all these different models, right? And then when you average the results, you're going to probably get something a lot more stable than a single model that you run on new data, right? So now, when it comes to the overall complexity, they're going to help with error rather than complexity, right? So when we use boosting, something that's going to happen is your inference is going to be slower, right? Because you don't need, not only you need inference from one prediction model, but you need inference from all other prediction models that you're using in your ensemble model. So therefore, it's going to be a little bit slower, right? So boosting makes your inference slower. Bagging makes your training slower, right? So that's the trade-off you have. You're improving basically the capability of your models, right, in terms of either variance or bias, but you're basically, that's going to come at the cost of taking longer time, either for inference or for training, right? So in a sense, you can say that complexity of your training in terms of the model is not changing, but because you're doing that multiple times, 100x, 1000x, it's just going to take that much longer time to train or do an inference, right? So complexity of the model doesn't quite change, but it takes longer, and you get a better result.
Thank you, Ryan. And this would be the last question. And yeah, other questions, maybe we can get in touch and, I'll post them in the Discord. So the last question is it a good idea to use very powerful TPUs to speed up a very complex model, or is it better to start with something simpler and then scale up?
Mm-hmm. So the question is, just trying to understand the question a little bit better. So is it a good idea to use a super fast big GPU and all the data we have, or using part of the data in a simpler model? Is that what this question is about?
I'll read. It's
Sure.
similar. Is it a good idea to use very powerful TPUs to speed up a very complex model? Or is it better to start with something simpler and then scale up?
Mm-hmm.
So let me also paste this in the chat.
Sure. Thank you. Very powerful TPU to speed up a very complex model, or starting with something simple. Okay, so we're I think we're talking about two different things here, right? So we're talking about how powerful your machine will be, right, for computation, to speed up the computation, or we better start something simpler and then scale up. So I guess the thing here is, what is the objective, right? So what is exactly the objective here? I would say my principle for machine learning, just like a lot of other things in life, is fail fast, succeed fast, right? If you can fail fast, why not, right? That's going to give us a lot of time to improve and come back stronger, right? So I would say, if you have a better machine that you can use it, right? Because you can use all your data, you can use a complex model, but also I feel like this comes back to one of the comments I made earlier on, is starting with something simple, right? So when we say starting something simple, it's relatively to the complexity of the data and complexity of the task. So for example, I'm never ever, by that comment, I never ever mean that if you are building a self-driving car, start with linear regression, right? So you know it's not going to work, right? So that's something to keep in mind. So we say it starts relatively simple, right? So for example, if you have option A, B, C, D, maybe you start with something that is simpler first, right? But not the most simple thing in the world, because it should kind of match the complexity of your data and task in hand. But in this particular case, I would say if you have a very powerful TPU, try all your data and a reasonable model. And if it doesn't work, you're going to know it very fast, right? Rather than, so a faster TPU will allow you to experiment with all your data and know the results sooner than later. And I would say that's a good thing.
Thanks a lot, Ryan. Just to let you know, we also have a feedback in Q&A, and that says, please bring Ryan back for some more sessions. Great insights. So I think now we're gonna wait for your availability, and certification series or not, we would love to see more sessions by you. And they are really great, detailed, and yes, we all would love that.
Thank you very much. I would love to be back, and it was a pleasure. I really enjoyed that. I think we got a lot of very, very interesting question, and thank you very much, everybody, and thank you for having me.
Thank you, Ryan. So let's move forward. Let me share my screen, Ryan. Okay, thank you. I hope you can see my screen. Perfect.
Yeah, we are able to see.
Perfect. Thank you so much. So yes, this has been a lovely session with Sam's experience on starting with regular expressions to using AI models and showcasing us the Airbnb project. So thank you so much, Sam, for delivering that. And I think it gives the idea to everybody how to kind of go into cross domains, cross industries, and bring up a very impactful product or solve a problem. And having said that, thank you, Ryan, again for detailed explanation on understanding the balance between model complexity, error, which is essential, I think, for both newcomers and the veterans in machine learning, as it forms the foundation of building effective models, that generalize well or unseen data. Now, moving on to this next session that you see on the screen, it's happening on March 16. Margaret from GDG Seattle would be the instructor for this session, and hopefully we'll bring another lightning talk for you, which is useful for you, and you get inspiration to come up with your own solutions to the problems you see in day-to-day life. So the next session focuses on cloud-based AI development environments and leveraging Google's AI technologies, including Jupyter Notebook integration, serverless machine learning training, and possible discussion on human labeling service for data accuracy. Moving on. Okay, let me first give you the good news here. Somebody asked in the chat about the discount vouchers. So the good news is that we have confirmed we'll receive a few discount coupons from the Google team, although the exact number is still pending. So considering these are limited coupons, they will be distributed based on participation in all the 6 sessions and sharing credentials on Discord from the courses that you complete. And on LinkedIn, tag our GDG study channel on LinkedIn when you share your credentials for the courses you complete. About the number of vouchers that we have, we'll share more details once we receive them, hopefully by next week. And they'll be, just to give you an idea, they'll be valid for around 1.5 months. So we would just request you for your support to fairly distribute them among our attendees. If you're somebody who is joining, let's say today, or you somehow missed the last sessions, that's okay. please go through the session plan that we have in the document of links that we just put in the chat. Please go through the session plan, try to complete all the labs and complete the courses, so we at least know that you are dedicated to professional machine learning certification, and you know, the other person do not miss the chance of getting that voucher. You know, if you think you're not going to take the exam, so give another person chance, and if you're doing it, share the credentials so we can track your progress there. And yes, let's move on to the next one. So as discussed last week, we have built with AI. If you are local and if you do not have any visa issues, please do travel to the Build with AI on April 20th. We would love to see you. We are not sponsoring the accommodation and the travel expenses at the moment. But having said that, it's always fun meeting you all virtually, and would be fun meeting you all in person. And with that, thank you everybody for joining. Let me know if you have any questions, or feel free to put them in the chat in Discord. Thank you.